Okay, lesson 3 for today, what we're going to be focusing on is the properties of multiplication to solving rational numbers for their multiplication and division problems. So we're looking at the properties now. Last week we focused on properties for addition. This time we're focusing on the properties of multiplication. Okay, remember we said that there's really not much of a properties going on for subtraction or for division because everything gets converted into either addition or multiplication. So we focus on those properties instead. Okay, so properties of multiplication, just like addition, we had associative property and commutative property. Remember, associative property is you focusing on the grouping. Commutative property is focusing on the order. Okay, so those are some things that you want to make sure that you're focusing on. Associative focuses on the grouping of the numbers. Commutative focuses on the order of the numbers. Okay, we also talked about how you had identities. When we talked about additive identities, that meant that if you add 0, the number will stay the same no matter what. No matter what the number is, if you add 0 to it, it'll always remain that same number. Multiplication has identities as well. It's got 2 identity problems. You have identity property of 1, meaning that if you multiply any number by 1, it'll always give you that same resulting number. And then you have a 0 property, that if you multiply any value by 0, you're always going to get 0. Okay, so those are 2 different identity properties. And then we've got the distributive property. And distributive property is a combination of multiplication and addition. It's where you've got multiplication on the outside of your grouping, and you've got addition or a sum, or even subtraction, bless you, on the inside of your grouping. And what it says is that anything that's on the outside can get distributed by multiplication to each term on the inside. So for example here, if we have 4 times the quantity of 1 plus 2, you can distribute that 4 to the 1, so you can do 4 times 1. You can also distribute it to 4 times 2, and then you would add those products together. Okay, so those are basically stating that they are written in the same manner. Now you will be practicing this. It's more common to practice this when you've got variables. Who remembers what a variable is? When I say the word variable, what does that mean? Nathan? A number that is unknown. And so what do we usually put in its place if it's an unknown number? An X or a Y or a Z or any other kind of letter representation. Okay, so we tend to use that distributive property when we are talking algebraically, when there is variables involved as well. Okay, we do have the inverse property of multiplication down here at the bottom. The inverse property of multiplication indicates that you can multiply by a reciprocal, and that's basically the same thing as dividing. So if I said, hey, I'm going to be doing, A divided by A, it's the same thing as saying A times 1 over A. Okay, so you do have your reciprocals. Your inverse property also indicates that it can be written in the reverse. Okay, so you can simplify them out. Again, written right here, if we have 36 divided by 4, it's the same thing as saying 36 times 1/4. So you actually are changing your division into multiplication of your reciprocal. You guys might have heard it more of like keep, change, flip. Okay, KCF, keep, change, flip. It's the same idea. You are multiplying instead of dividing, and you're doing the reciprocal instead of the original number. Okay, 1 over that number. All right, go ahead and flip it on over to the next. These are really quick notes for today because it's really not a whole lot to go into. So we're doing just like we did last week, where we're going to identify where the change occurred. Where did our changes occur? And what kind of property could we use in order to justify that change? So taking a look at the original problem, we've got this original problem right here of 8 divided by negative 2/3 times 7 divided by negative 2 times negative 3. And then we're rewriting it as 8 times negative 3 over 2 times 7 times 1 over 2. That there should be a negative there. I don't know why that doesn't have a negative there. So actually, you know what we're going to do is we're going to instead change this to a positive up here. Change that to a positive too up the top. That way it makes it a little easier. All right, and then times it by negative 3. So what I'm seeing occur is this change. I'm going to highlight in pink where my changes were. So I originally had started off as a dividing by negative 2/3, and I changed it to multiplying by negative 3/2. I had originally had dividing by a 2, and now I have it multiplying by a 1/2. What property was that called again? Look back at your property lists. What property was that when we said we were going to change division to multiplication? The inverse. Okay, so it's a multiplicative inverse. So off to the side, I'm going to write down, this is my multiplicative inverse. All right, for step 2. With step 2, the only thing that happened to change is located right here, this negative 12. We don't have a negative 12 written up here, but what's now missing from step 1? What information is now currently gone? Up here? Well, go from the beginning. Do we have an 8 anymore? No, so that's gone. Do we have a times negative 3/2 anymore? No, that's gone. Do we still have a times 7? Yes, we do. We still have times 7, times 1/2, and times negative 3. All of that part's still the same. So the part that changed was this portion right here. This 8 times negative 3/2. All we did was actually multiply those together to get negative 12. So there wasn't really much of a property used so much as we just actually worked it out. We went ahead and multiplied 8 times negative 3/2. Okay, so what I want you guys to do right now is go through each of the steps, identify where the change is, and either what property was used or justifying what they did. You're going to do that independently first, and then I'll let you guys talk together. Okay, we went from step 2 to step 3. Who can raise their hand and tell us what property did they see happened from step 2 to step 3? Christiana? Not commutative. Commutative changes the order. So the order itself didn't actually change anything too much in here. More so as it's what instead, Nathan? Associative. You're grouping things together differently. So yes, it did pull something from a different order, but you're actually placing them into the groups. Remember, if you've got that grouping, that would be your associative property. Okay, so what's occurring right here is we've now created a group using negative 12 and 1/2. So that's going to be our associative property. Okay, and then to go from step 3 to step 4, what did we do? Jean-Luc?
Multiply negative 12x by 1/2.
Just negative 12, not x. There's no, that's a multiplication symbol for right now. But yes, we just multiplied. All we did here was multiplied negative 12 times 1/2. Okay? Then what about step 5? What occurred in step 5? Jeremy? Yeah, we just focused on multiplying the 7 times that negative 3 that occurred. Okay, so we multiplied 7 times negative 3. Some people might have even said that it could be technically commutative property because you are working the problem out in a different order. So instead of going in order, normally if you went in order, you would have done negative 6 times 7, right? Because that's the order. But we kind of went out of order. So we went to 7 times negative 3 first. You could have also stated that there was commutative property there. You switched the order of how you were solving the problem. And then, of course, the last one is just multiplying those values together. Okay, so we multiplied negative 6 times the negative 21, which that should have been a positive 126. You got to excuse some of the errors when I pull things off of our county. All right. Now, taking a look at distributive property, applying the distributive property. Distributive property is actually really helpful when you are multiplying integer values with rational numbers, especially if those rational numbers happen to be mixed numbers. that you can basically pull apart your mixed number. Remember last week we said the opposite of a sum is the sum of its opposites, right? So instead of having 2 3/5, I could rewrite this as 2 plus 3/5. And then I've got this negative 10 that's out on the outside. Now I can utilize this negative 10 and distribute it to each of the components on the inside of this multiplication problem. So we have a negative 10 that we can now go ahead and multiply by 2. We also have a negative 10 that we can now multiply by 3/5. And then we can just add these values together. So what's negative 10 times 2? Negative 20. Okay, what's negative 10 times 3/5?
Negative 30.
Negative 30/5, which can simplify to what? Negative 6. And then we're just adding that. Okay, and the negative 20 plus negative 6 is negative 26. Okay, we're going to stop here now. Let me go ahead and break this apart for you, this one. So we have the negative 14 that's going to go onto the outside. Inside, we're going to pull apart the mixed number. So that's going to give us a negative 3 plus a negative 5/7. Okay, remember since the mixed number was negative, then both the whole number and the fraction, when you pull them apart, are going to be negative. And then we're going to go ahead and distribute. So we're going to do negative 14 times negative 3, which is going to come out to a positive 42, plus you're going to do negative 14 times negative 5/7. Okay, when you multiply those together, that's going to give you a positive, right? Because it's a negative times a negative, you're going to get a positive 10. Okay, and then we're going to combine those together and you're going to get 52 as your final answer. Okay, for problem 3, they already have it pulled apart for you. It's already been pulled apart, so you're just going to go ahead and do your distributive property. So we're going to do negative 5/7 times 10, which is the same thing as 10/1. That's going to come out to a negative 50/7. Then I can change this. Remember, we can change the subtraction into addition and then change this into the opposite and make that a negative 1/5. So we're going to multiply negative 5/7 times negative 1/5, and that's going to give us a positive 1/7. Okay, so now we're just, since they're both the same denominator, we know that the denominator is going to be a 7. And then negative 50 plus 1 is going to come out to negative 49. But negative 49/7 just comes out to negative 7. So your final answer is going to be a negative 7 for there. Okay, we're going to stop here. Load it into Google Classroom as your assignment. It's a Delta Math. It does go quickly. You have a lot of different sections that need to be completed, but each section has only 5 little questions in them that you need to get correct. It moves fast. There's quite a few of them that are just plot these numbers on the number line and tell me what the distance is, or create the number line addition problem, or rewrite the problem into an additive inverse, so you're not solving but you're rewriting and stuff like that. Then you've got some that are actually applying properties.